So in this video, we're going to be solving systems of equations by graphing. And really, this shouldn't be too difficult for us to do as long as you know how to graph lines. Remember, we want to graph lines most often if they're in the form slope-intercept form, y equals mx plus b. And that makes it a lot easier. So let's look at these two equations here. This is called a system of equations because it's just, it's more than one equation. So we have equation 1, which is y equals 2x plus 4. And if I'm going to graph that, this is what it looks like. We start at the y-intercept. The slope is a 2. It's a 2 over 1, right? So we're going to go up 2 over 1. We can also go down 2, left 1, down 2, left 1. And you can follow that pattern, and you'll find several integer solutions for that equation. You connect your line through there and you have found the pathway of solutions for equation 1. Now I'm going to do the same thing for equation 2. I'm going to start at the y-intercept, and remember my slope is a 1 over 1. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. I also want to go down and back, down and back, down and back, and make sure that I continue this. That makes the best lines when you put more points on there. Okay, I didn't draw that perfectly, but what you can see is that there is a crisscrossing right here, and that is a point that represents a solution not only to equation 1, but it also is a solution to equation 2. So that is the solution to the system. What is that ordered pair? It is -2, 0, and that is how you find the solution to a system. So if I plug this in to both of these equations, you're going to see that it does make sense. This is the x value. So where it says x here, I put -2. And this is the y value. So I put the 0 in the place of y. If we calculate, we get this. 2 times -2, well, that is -4. We get 0 over here. -4 plus 4, that is 0. So 0 equals 0. Yes, it does. If I plug in those same values, x as -2 and 0 for the y, then I would get 0 equals, well, -2 plus 2 is 0. And so, yeah, we got that is true. The ordered pair, -2, 0, is the solution for both equations, and therefore is the solution to the system. That's as simple as it is. You just graph both of these. So here's the green equation. I'll do it in green. We start at -4. We need to go down to, I can't go down to, so I'm going to go up to 1, 2. But remember, that's over a 1. So I'm going to go up 2, and I want to go to the left 1 because remember, our slope is negative, and so I want it to go downhill. So I'm going to do that. And there are the solutions to the first equation, which I have identified as the green equation. Now I'm going to do the red equation. So we're going to start at the +4. Remember, that's a 6 over 1. Once again, I can't go where I would naturally want to, which is up 6. So I'm going to go down 6. 1, 2, 3, 4, 5, 6. And I would normally go to the right, but if I go down and to the right, you'll see that that would make a negative slope. This is positive. So I'm going to go down 6, and I'm going to go to the left 1. And if I went down 6 again, I'm off the graph. I can draw my line through those points, and you will have already found this intersection spot. Now, what is the ordered pair there? What is the x and y value there? And the answer to that is -1, -2, which means x is -1, y is -2, and if I plug that into both of those equations, it would make both of them true. So the only way this really gets any more difficult is if the equations aren't in slope-intercept form. So these actually still are in slope-intercept form. I want to make sure that there's an example of rearranging those and making us go through that. But right now, it doesn't seem to be any more difficult than what we just did. So -3, I'll use green again for the first one. -3, put my y-intercept there. And it says to go down 7. Well, I'm going to have trouble going down 7, because it's going to take me off the graph. So I'm going to go up 7. 1, 2, 3, 4, 5, 6, 7. And then I'm going to go to the left 4. So it's kind of like I'm not using the negative on the 7, so I'm going to have to use it on the 4. So I went up 7 and then left 4. 1, 2, 3, 4. And that will make a negative slope if you look at that. So draw your line through those points. Not perfect, but you can tell where I was going. And then I'll do the same for the second equation, which I'll allow to be red. Start at the positive 2. We're going to go down 1, and we're going to go to the right 2. 1, 2, down 1, 1, 2, down 1. Can't do it again. Could go up 1, back 2, up 1, back 2, and draw that line. And I will also find my intersection right here. And so that blue dot is on both lines, which means it is a solution to both equations and thus making it a solution to the system. So what is the ordered pair there? Well, it's a negative 4, positive 4. Negative 4 is my x value. See, if I went down here, you'd see negative 4 on the x and positive 4 on the y. That is the solution to the system. So the only thing that's going to get difficult about this is if you don't know how to graph a line, if it's not in slope-intercept form, or if you have trouble understanding how to interpret an ordered pair. Here's one that has, they're not in slope-intercept form. So let's go ahead and take a look at that one. So this is my blue equation. Whoop, there's my blue equation. I need to rearrange that. So x plus 3y equals negative 9. I want to get y by itself. So I'm going to get rid of the x term first, so that the only term on the left side is the one with the y value, or the y variable. Remember, we write this in this order, negative x and then minus 9. And then I have one more step to get the y by itself. I have to get the 3 to go away. And we're going to divide by 3, divide by 3, divide by 3. And you'll have this for your blue equation. You'll have y equals, there is a 1 here. This fraction does not simplify, and that's not a problem for a slope. A fraction as a slope is just fine. And then a negative 9 divided by 3 is negative 3. So once again, once it's like this, graphing it can be as quick as there's negative 3, down 1, to the right 3 from there. Down 1, to the right 3, up 1, to the left 3, up 1, to the left 3. Can't do that anymore. Draw your line before you go any further. Those are the solutions to the blue equation. We need to now find the solutions to the green equation. In order to do that, I need to take the green equation and get y by itself. And this one is a little bit easier because in order to get y by itself, all I really need to do is subtract the 2x from both sides. Once I've done that, I would get this equation. Y equals negative 2x, and that's a positive 2. So let's graph the green equation. Start at the y-intercept. We're going to go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. And we did already find that intersection. The last part of this will be identifying that intersection as an ordered pair. The solution to the system is this ordered pair, and it is the ordered pair 3, negative 4. That is the only ordered pair that will satisfy not only one of the equations, but both of the equations. So here are your options. It's possible to have lines just cross like they do here. The solution for this system would be the ordered pair negative 1, comma 1. Lines that intersect, like in that example, have one solution, one ordered pair that would satisfy both of the equations. If the two lines are exactly the same, they have intersection. Um, they have an infinite amount of points, that are on both lines. And that's actually down here. It says two equations that result on the same line have infinitely many solutions to the system. Okay, infinite does not mean all. What I mean by that is this ordered pair is not a solution to this system, nor is this one or this one or this one or this one or anything. It doesn't have to be just integers. But the red dots that are on both lines, they are solutions to the system, and there are an infinite amount of those. And the last situation that could occur is that you have parallel lines. And if you know enough about equations of parallel lines, you'll be able to identify when lines are parallel before you even graph them. But let's say you graph them both and you realize, oh, those are parallel. Well, there is no point that is on the blue line and on the red line. It's impossible for a point to lie on two parallel lines. And therefore, there is no solution if the lines are parallel. So that is the entire lesson. That is all you have to understand how to do. You can quickly see how this has built upon previous concepts that we have learned. We know how to read an ordered pair, we know how to graph lines, and we want to make sure we understand that the lines graphed are solutions to those equations. So all we're looking for is intersection. If we can find the intersection of two lines, we have found the solution to that system. If you have any questions, let me know.